Hello everyone. Through this video, I'm taking up the questions of the chapter Differentiation from the NCERT textbook, which is there in chapter 5. I'll be taking up first the exercise 5.2, which starts with the differentiation of explicit function. Explicit function means the function where y, a dependent variable, depends upon the independent variable x through some rule. For example, the first one, it's sine of x square plus 5. So this is a composite function connecting y and x. So the derivative of this function is, we have y is equal to sine of x square plus 5. The derivative, to differentiate this function, we need to read this function in the proper order, as this is a composite function. The order in which you will be reading this function, in the same order you need to differentiate, and all the derivatives that we have is to be multiplied for the derivative of y with respect to x. So the derivative of y is dy on dx. Now here the first function that you'll be reading is sine of. So the first derivative that will come across is the differentiation of sine function. The derivative of sine is cosine. So it's cos of x square plus 5. Then the next function that we have is the algebraic expression attached to it. It's x square plus 5. So we differentiate this function x square plus 5. Now the derivative of x square, the derivative of x to the index n is n x to the index n minus 1, that is 2 minus 1, which happens to be 1. So we just write it as 2x plus the derivative of 5. 5 is a constant. The derivative of constant 0. So it's just 2x, the derivative of x square plus 5. Hence the derivative of sine of x square plus 5 is 2x cos of x square plus 5. Now we come to the next question, the second question. That's y is equal to cos of, listen to the order that I am reading up for the function. It's cos of sine x. So the first function that I read was cos function. For when we differentiate y, we differentiate the cosine function first. So dy on dx, that's equal to the derivative of cosine, its cos derivative, it's minus of sine x. Then the next function that we'll be reading after that is the derivative of sine x, which is cos x. So it's cos x multiplied to sine of sine x. Hence the derivative of cos of sine x is nothing but minus of cos x multiplied to sine of sine x. Please do not misunderstand this expression as sine square x. Sine square x happens to be square of the ratio. This is a composite function. So leave it in this form. This is a form that we have to leave this expression as. The next function is the fourth question. It is y is equal to sec of tan of root x. So here we see this function has three functions. This is a combination of three functions. Secant function, tangent function, both trigonometrical function, and finally a algebraic expression. So the function has to be read in the proper order. It's read as sec of tan of root x. So its derivative comes out to be, first, the derivative of sec function. The derivative of sec function is, derivative of sec x is sec x tan x. So we'll write it this way, sec of the expression that you have attached to it, sec of root tan x, sec of, sorry, this is tan of tan root x. Then the next function, this is the derivative of the first function that we have as sec x. Then the next function that we have is tan function. So the derivative of tangent function is sec square. So this will come out to be sec square root x. The third function that is read is root x. So the derivative of root x is, this is to be read as x to the index half. So the derivative of x to the index half is half of x to the index half minus 1, which comes out to be minus half, which will be writing it as upon root x. All these derivatives finally connected through a multiplication sign. So the derivative of sec of tan root x happens to be 1 upon 2 root x, sec square root x, sec of tan root x, tan of tan root x. Again, here please do not write this as tan square root x. It's a composite function. The next function that we have is the sixth question. That is y is equal to its cos of x cube multiplied by sine square x cube, x to the index 5. Now here, the combination of function is first the product rule. The product rule says differentiate one function at a time, keeping the rest of the function as constants. The first function that we'll be reading is cos of. So this is to be differentiated first, keeping sine square x to the index 5 as a constant. So the derivative of this function is dy on dx, that's equal to derivative of cos function. Now this function, which is again a composite function, so we have it as cos of x cube. So this is differentiated first as cosine function. So the derivative of cosine is minus of sine of x cube. Then the next function that we have in it is x cube. So its derivative is 3x square. As I said, the remaining function here, it's only one function. It's just to be multiplied. So it's multiplied. So we prefer to use, when you have more than one term, we prefer to use brackets. So the second expression that we have is put in a bracket, which is sine square x to the index 5. So the function, first function differentiated is cosine multiplied by the rest of the functions plus, that's the product rule. The second function is to be differentiated, keeping the first function as a constant. So we'll put this in a bracket. It is cos of x cube. Now for the derivative of the next function, that is sine square x to the index 5. Again, read the function. The function is read as square of. So it's an algebraic expression that we are reading first. So the expression that we have is square of. So square of function, we treat it as x to the index n. So it's x to the index 2. That is, derivative of x to the index 2 is 2 times x, that is the function that we have, to the index 1. Multiplied by the next expression, that's next function attached to it, that is x to the index 5. X to the index 5, a normal algebraic expression, the derivative of it is 5x to the index 4. So this way we have differentiated the function cos x cube multiplied by sine square x to the index 5 using the product rule. It's a product rule between two composite functions. So I'll repeat once again. The product rule between two functions is differentiating one function at a time. So I differentiated first the first function, that is cos of x cube. keeping the next function sine square x to the index 5 as a constant, it is just multiplied to it, plus the first function multiplied by the derivative of the next function, that is sine square x to the index 5, which happens to be 2 times sine of x to the index 5 multiplied by 5x to the index 4. So this is the product rule for in differentiation. The next function that we have is the 7th question. The 7th question, again, it's a composite function which is 2 times under the root of cot of x square. So here also we find that the function looks like it's a product of two expressions, that is 2 times under root of expression. But since this is 2, it's a constant, it's just attached to the derivative of the function when you differentiate the function. So this function is basically a composite function which has 3 functions in it: under the root, cot function, and an algebraic. So there are 2 algebraic expressions along with the trigonometrical expression. So to start with the derivative of this function, as I said, 2 is simply attached to it. So we start with first function that we read, that is under the root. So under the root, it's nothing but something to the index half. So something to the index half's derivative happens to be half of that quantity to the index half minus 1. So that comes out to be under the root 1 upon under root of the expression, that is cot of x square. The next function that you have is the derivative of cot. The derivative of cot function is minus of cosec square, the expression. The next function that you're reading is x square. So the derivative of x square happens to be 2x. So this is how we differentiate the function y is equal to 2 under root cot of x square. So the rest of the questions that you see in the textbook from 1 to 8, not the 9th and 10th question, only 1 to 8. The rest of the questions, I assume that you can attempt the questions taking the help of these questions.